Next, continue to number 2. X squared plus 4x minus 5. First, we have to convert this into the complete integral form. If you remember, so we prepare the bracket square minus n minus 5. So we have x squared here, so this is x, plus 4x divided by 2, plus 2, yeah? So it always divided by 2 and x. So it's plus 2, and then here minus 2 squared. Yeah, this number squared. It's always like that. So we simplify, it's x plus 2 squared, and then minus 9. So from here, we know that the vertex will be negative 2, negative 9, and this will be the x squared, so use here. So if we draw, like this, so it will be negative 2 and negative 9. So this is the vertex, and then it will be used here, like this. So once again, for x element real number, for all values of x, we can see that the minimum range, the minimum y values in here is negative 9. The maximum is infinite. So the range will be y is greater than or equals to negative 9. Second one, x greater than 0. So we have to find the f0. The f0 is negative 5. So here is negative 5. So this is exclusive. So x is greater than 0. So it's moving to the right. So the function will be moved upwards. So we can see that this is 1, 1 function. So the range will be taken from this border. So y is negative 5 and up. So greater than negative 5, exclusive. Now, x smaller than negative 4. So we find negative 4. The negative 4 is negative 4 plus 2 is negative 2 square. 4 minus 9, it's negative 5. So here is negative 4. Smaller than. So it's going to the left and the function will go up. So again, this is 1, 1 function. So we can just take the value for the range, and it's from negative 5 and above. So it's y greater than negative 5. And then the last one, negative 2. So f negative 2 and f1. F negative 2 is negative 9, and f1 is 0. So from here inclusive until here 1 inclusive. So it will be this. So again, this is 1, 1 function. So it will be y between negative 9 and 0, and both are inclusive. That's for number 2. Number 3. Let's start with 2. So we have to factorize the 2. So it's become 2 x squared minus 3x minus 7. And then we can do this, the complete integral square form. So we prepare the other thing that stay the same. And we prepare the bracket again and minus here for the complete integral square. So this is x squared. So this is x minus 3x become minus 3 over 2. And this will be minus 3 over 2 squared. So we simplify. It's 2 x minus 3 over 2 squared minus 9 over, okay, put bracket here, 9 over 4 minus 7. So 2x minus 3 over 2 squared minus 9 over 2 minus 7. 2x minus 3 over 2 squared minus 23 over 2. So again, the vertex will be 3 over 2, negative 23 over 2, and this is a U shape. So this is 3 over 2, and this is negative 23 over 2. Here, U shape. So for the first one, x element real number, the range will be y greater than or equals to negative 23 over 2. So it's always greater than the lowest point, the minimum point. Now, x greater than 4. So find f4. So f4 is, we put 4 here. 4 square is 16 times 2, 32. 32 minus 24 is 8 minus 7 is 1. So 4 is 1. So that means 4 will be around here. So this is 1 exclusive. And then greater than, so it's up, yeah? When it goes right, so the function goes up. This is 1, function, so the range will be y greater than 1. The third one, x greater than, smaller than negative 2. So negative 2 will be, we put negative 2. So it's 4 times 2, 8. 8 plus 12, 20 minus 7, it's 13. So 2 here, negative 2 here, so this is 13. And smaller than negative 2, so when it goes left, it goes up. So this is 1, function. So y is greater than 13. This is 13, yeah? And the last one again, we find 0 and we find 3. So if you put 0, it will be negative 7. Inclusive. So this is negative 7 inclusive. And if we put 3, we have 3 squared, 9 times 2, 18 minus 18 plus minus 7. So it's minus 7 as well. But here will be exclusive. Exclusive, yeah? That means the function will be in this interval. And you see that this is not 1, function. So we have to find the minimum and the maximum. The minimum here is negative 23 over 2. So y will be between negative 23 over 2 inclusive because the minimum point is within the interval, the domain, and the maximum in here is -7. We have two -7, inclusive and exclusive. So we take the inclusive because the -7 is there. So take the inclusive. Yeah, even though the 3 here is exclusive. That's for number 3. Number 4, let me copy the question. Greater than 0, smaller than -3. Greater than 0, smaller than -3, and -1 until 5 inclusive. -1 until 5 inclusive. I change the color. I use black, yeah. X, -1 until 5 inclusive, yeah. Now, so let's start with the first one. We have to do the completing the square. But since the x squared here is negative, so we have to make it into positive. I will write it here. So it's 5 minus 2x minus x squared. This is become plus because I factorize the negative out from the bracket. And then I can rewrite this as 5 minus x squared minus plus 2x. And we can do the completing the square for this. So it's 5 minus, we prepare the bracket. So it's bracket and minus. So this is x plus 2x become 1. Yeah, divide by 2 and x. And then minus 1 square. So it's 5 minus x plus 1 square plus 1 equals to 6 minus x plus 1 square. So the vertex will be -1 and 6. And since the x here square here is negative, so it will be a u LCM. So the draw will be like this, -1 and 6. So -1, 6, and this is an M shape. So for the x element real number, so the maximum will be 6. The minimum is -infinity. So y is smaller than or equals to 6. That's for the first one. And for the second one, x greater than 0. So we find the f0 first. The f0. So we put it and it equals to 5. So 0 here is 5 and exclusive. It goes to down. Yeah. So smaller than 5. Y is smaller than 5, exclusive, because the x is exclusive. X greater than 0 is exclusive. The third one, smaller than -3. So find -3. The -3 here is -3 plus 1 is -2, 4. So 2, yeah. 6 minus 4. It's 2. So where is it? -3 is 2. Here, -3. Here, 2. Smaller than -3. So it goes to the left, the function goes down. So it's y greater than, smaller than 2. Yeah, this is one function, so we just take the value at the border. And the last one will be from -1 until 5. So for f -1 and f5. For -1, it will be 6, and 5, it will be 5 plus 1, 6. So it's -30. So that means it will be here. 5 is here. Inclusive. -1 will be here, exclusive. And it will be this. And this one is 1, 1 function. So we can just take to the value at the border. Y should be. The lowest is -30 here. So it's -30 and inclusive. And the highest will be 6, exclusive. So this will be the range for the quadratic function. You can try this exercise for your practice. And then I move to the other function. Now, again, we have square root. So if you remember, the condition of the square root function, the term inside the square root cannot be negative. So that means the term inside the square root should be greater than or equals to 0. It's always positive and 0 and positive. So we have to find the x values that make this expression greater than 0. So this is 3x greater than or equals to 9. So x greater than or equals to 3. So for this function, x cannot be element of real number because we have to ignore the negative values until 2. Because the x should be start from 3 and beyond. So the domain will be x greater than or equals to 3. And if we put 3 to the equation, so we put 3 here, so it's 0. So 3, 0, and beyond. So that's why the range will be from 0 and up. So it's greater than or equals to 0. That's the first one. How about the second one? X greater than 5. This function is 1, 1 function, so this one will be easy because f5 will be equals to 15 minus 9, so it's square root of 6. So when I have 5 here, it will be a square root of 6, exclusive, and it's going to the right, so it's going continuing to the up infinity. So we can say that the range will be y is greater than square root of 6. And for the third one, smaller than 9. So again, this is 9. So I can find f9. F9 is 30. 3 times 9, 27 minus 9 is a root of 18. So this is root of 18. And we can see that it's from root of 18 and then go down until stop at 0 because the domain is restricted for x greater than 3. So we have to restrict the domain. So x should be between 3 until 9. It's only 3 until 9. And the range will be from 0 until root of 18, while the 0 is inclusive. And the last one, 4 until 6. This will be easy because this is one function, f4 and f6. So f4 will be square root of 3 and f6 will be 3. So 4 is here. Inclusive, it will be square root of 3. And 6 will be here. Inclusive, and this is 3. So this is the value. And the y values are from square root of 3 inclusive and 3 inclusive. I skip number 2, yeah. I go to number 3. So for number 3, I will make my own domain, yeah. So this is a reciprocal. So I do 3 here. This is a reciprocal function. And the one that we have to remember is the denominator cannot be 0. So from here, we can say that the 4x minus 1 cannot be 0. So that means x cannot be 1 over 4. Now, this equation is called as the vertical asymptote. Reciprocal function has two asymptotes, vertical asymptote and horizontal asymptote. What is asymptote? Asymptote is the line that never being passed through by the curve. So the vertical asymptote is taken when the function fails. So we know that from here, the function fails when x is equals to 1 over 4. You cannot put it because if you put 1 over 4 to the x, to the function, it will equals to 2 over 0. It will become 2 over 0. And we cannot do that. So that's why it's vertical asymptote. So when you draw it, there will be a vertical asymptote here, 1 over 4. And the other one is the horizontal asymptote. So for the horizontal, is when x goes to infinity. So we put x as infinity. So it's 2 over 4 times infinite minus 1, which is 4 times infinity is infinite minus 1. It's still infinite. It's 2 over infinity, which is approximately 0. So the horizontal asymptote will be y is approximately 0. So this will be, the x-axis will be the horizontal asymptote. So we know that the curve will never pass through these two asymptotes. Okay, now how do we draw it? We sketch, yeah? If we back to the equation, when we put x in increases value, yeah, if x is increasing, the denominator will increase. And the value, because it is inverse proportion, so the value will be decreasing. So it will be like this. It never touches. And for the negative value, it the same. It will never touch the asymptote. Now, so from here we have the 1, 1 function. So for the domain, if I have a domain of x greater than 1 or equals to inclusive. So I can just find the value of f1. So f1 is 2 over 4 minus 1. So it's 2 over 3. So I have 1 here, and this is 2 over 3. And you see that the function will go decreasing here. So the range will be y smaller than 2 over 3 inclusive. But remember that this value is not continuing to the negative infinite, but it will be approximately 0. So technically, the range will be limited from 0 as the minimum point to the 2 over 3 inclusive. So that means this will be the range of this function. So between 0 until 2 over 3 inclusive. 0 is exclusive because it will never be 0. And also if I put x, another example, if x smaller than negative 1. So it will be here kan, negative 1. So I can find x negative 1 will be equals to 2 over negative 4 over minus 1. So it's negative 2 over 5. So this is negative 2 over 5. And it goes up, yeah, because the domain will go left. So it goes up. So that means the range will be, the maximum will be 0 now, because it will never touch 0. And the minimum will be negative 2 over 5 exclusive, because x is exclusive here. That's for reciprocal. And this another exercise for you to practice. Now, it's about composite function and inverse function. Composite function are the two functions that connected each other. Yeah, the one function is following the other function. So if we have gf function, yeah, that means we have to perform the x from the function f first, and then continue by the function g. So we put the last function first to replace the x of the other function. So for example, if I have fx equals to x squared and gx equals to x plus 3, so when I have gf, that means I have to start from f, and the f should be inputted into the x of g. So g, for example, I have g of 3. So that means I replace the 3. Yeah, I replace x with 3. So it's equals to 6. Now if I have g of fx, so that means I replace x by fx. So it's fx plus 3, which is, it will be x squared plus 3. So this will be the expression, the new expression of gfx. So this is not a multiplication, but this is a g following f. So it's a continuation, yeah, from a function to another function. That's called as the composite function. Sometimes we write the composite function in this notation. Sometimes we just put it into dot there with x over there. Now let's check f of g, f following g, f of gx. So f of gx means we start working from g and then input g to the f. So that means the fx is x squared and gx is x plus 3. So we put gx, replace it into x of the fx. So I can prepare. So f of gx is something square. This is the room. This is the house, yeah. And this is the thing that you input to the house. So the thing is x plus 3. So f of gx is x plus 3 squared. And from here you can see that g following f and f following g are not the same. Yeah, they are different because order matter here. Okay, we will continue to the next part for the domain and the range of composite function.